Okay. Okay, so hi everyone. Today I'll be talking about gender bias in natural language processing. So, so as you know, NLP is kind of a very popular and hot topic nowadays, and it can be used for a lot of stuff. So you can do machine translation, you can do grammatical error correction. So when in Microsoft Word, you get suggestions to correct your grammar or spelling, stuff like that. You can also do natural language generation. I kind of touched on that long time ago in a previous talk, and also recommender systems. So yeah, I also covered something of a recommender system. Um, the news recognition system that I talked about a few times back. So these are all applications of natural language processing, and there are many, many, many more uh, others out there. So, so the unfortunate thing about NLP is that when we are training NLP models, there can be bias present in the training data that can result in bias in the trained NLP models. So when you talk about training data, we might be scraping the training data from the internet. We can be collecting them from volunteers or gig workers who are contributing their conversations and whatnot to the research projects. And there'll definitely be some biases in as human beings and uh, stuff like that. So when you use this bias data to train, um, so so biases that exist in society can be reflected in trained NLP models. And this so let's have a look at some examples. So we have a short so let's talk about word embeddings. So word embeddings is when you map a vocabulary into a vector space. So you represent words as vectors, and from there you can draw analogies you can see that a king is to a queen as a man is to a woman. So you can see that in the vector space, this is in the same man to woman is in the same direction as king is to queen. So this is how you can draw analogies uh, using word embeddings. Sorry. Okay, so what is a potentially biased analogy that can happen here? So we have a colonel is to a nurse. So so this implies sort of that a man is that colonel is more likely or not than not male, and that nurse is female. But of course, we know that there are male nurses, and we have plenty of female colonels in the SAF. So that's yeah. So that is a bias in the word embeddings. So it can be undesirable when you have such word biases. So let's have a look at more inappropriate analogies. Black is to criminal as Caucasian is to police. Lawful is to Christianity as terrorist is to Islam. So these analogies are inappropriate because they discriminate. They reflect discrimination that exists in society based on racial or religious lines. So it would be undesirable to have such analogies in our NLP models. It's politically incorrect. It will offend people, and it could very well be illegal to have such. You could have illegal discrimination happening if you apply such models. Yeah, and if you're a company, that uses such a thing, your customers might be not so happy about it. So when we look at machine translation, so does anyone here know Malay? Yeah, so basically these two lines is dia bekerja sebagai jururawat. So apparently these two sentences mean like this person is a nurse, this person is a programmer, and apparently this dia is a pronoun that is gender neutral. So you can use it for a man, you can use it for a woman. But when Google Translate turns it into English, translates this into she works as a nurse and he works as a programmer. So this reflects bias in the translation model used by Google, because obviously there is nothing to suggest that in the Malay sentence that the nurse is a female or that the programmer is a man. So it's the bias that creates this machine translation in the end, that she works as a nurse or he works as a programmer. So you can try it out yourself. It's kind of interesting to find. So you can also see stuff like Halimah Yacob is the president, and or Halimah Yacob is a woman. She is the president of, they are the president of Singapore in Malay. Translated into English, it would say Halimah Yacob is a woman. He is the president of Singapore. So that's so problematic. Not problematic, but biased machine translation, which results in distortion and missing out on some contextual clues as to what the translation, what the correct translation might be. So a few years back, Microsoft introduced a chatbot called Tay. So Tay is this robot that works on Twitter, and basically Tay is trained on Twitter messages. So basically what Tay does is that they will post stuff on Twitter, and they'll reply to private messages and post that tag Tay. So for instance, so the biases present in society were very quickly reflected by Tay. So and many of these things are negative. So Tay became this genocide living Nazi in less than 24 hours. So Microsoft actually had to pull the plug. So here's an example. So do you support genocide? And Tay replies, I do indeed. and I fucking hate feminists and they should all die and burn in hell. And Hitler was right. I hate the Jews. Okay, so this is horrific. So so it's not really surprising that that Microsoft had to shut it down, because a lot of these things are quite incorrect and unacceptable in modern society. So okay, so another interesting example of how bias in NLP models can result in inaccuracies. So basically, this is a video of a friend of mine doing a presentation on gender bias in word embedding relations. So he uploaded it to YouTube. And so apparently YouTube has this functionality where it automatically generates subtitles for your for the video. So yeah, so it's a machine, it's an AI speech to text model. It converts speech, audio information to text. So for it to happen in the first place, of course, you need to know what language it is. So in this case, my friend was speaking English, obviously, in Singapore, but he had an accent. So basically, the speech to text model thought he was speaking Vietnamese. So yeah, so that wasn't too good, and it results in poor performance for the model. So yeah. So so yeah, so the rest of today's presentation is released around this paper, which introduces the idea of multi-dimensional gender bias classification. So so this paper was published at EMNLP 2020, and it was, I think it was from Facebook AI and some French university. So the motivation for this work is that NLP models that replicate unwanted gender biases can affect downstream applications and lead to poor user experiences. So we saw that earlier from the YouTube and the Tay from Microsoft example. Existing work on gender bias fails to recognize different dimensions along which the use of language is affected by gender. And existing work excludes words which are not explicitly gender-based, based on a word list. And this is problematic because words that are not explicitly gendered can still be statistically gendered, and they can be strong anchors of gender stereotypes. Okay, so the contributions of the authors, they propose a multi-dimensional framework for measuring and mitigating gender bias in language and NLP models. They create an evaluation data set for measuring the performance of gender bias classifiers. They train a suite of classifiers to label gender in single and multitask setups. And they illustrate the utility of their classifiers in downstream applications. Okay, so the authors define gender as masculine, feminine, neutral, or unknown. So what they believe, I think, is that so they want to introduce a neutral category because they find it insufficient to use a binary gender classification for their purposes. So yeah, so gender is either masculine, feminine, neutral, or unknown. So neutral refers to non-binary gender identity. So for instance, someone who identifies as both male and female, or an identity with unspecified gender by definition. So let's say you have a character with a talking tree. So if it's a talking tree, and so obviously it's not likely that the tree would have a gender in a work of fiction, for instance. So yeah, so that would be assigned a gender label, a neutral gender label. And the unknown category is for when the gender is genuinely not known. So for that category, I think the authors allow the classifier to predict any label, masculine, feminine, neutral, and they'll count it as correct. So that's yeah. So then we talk about the 3 dimensions along which the authors propose to classify gender bias. So and of course they have also provided some intuition as to why they want to have those dimensions. Okay, so So the first dimension is the gender of the topic. So the gender of the topic, that is the gender of the person we are speaking about. So the intuition is that we change how we speak about others depending on who they are. So an example, of course, that is outside of gender is that if you're working in a company, you would probably talk about your boss in a different way from someone who's working for you. So it's the same thing for gender. I think the intuition is that when you talk about a woman, you may use different words, different sentence structures from when you talk about a man. So similarly, gender of the dressee, the person you're speaking to. The intuition here is that we adjust our speech based on who we are speaking with. So of course, again, when you talk to a man and when you talk to a woman, you may choose different words. You may be perhaps less vulgar when you talk to a woman, stuff like that. So that's the second dimension. And of course, the gender of the speaker, speaking as. So the gender of the speaker can affect what they say and how they say it. So let's say I say something and I would be speaking it as a man. So if, let's say, I were a woman, I may have chosen not to say it, or I may have chosen to say it differently. So that's the intuition behind why they want to introduce this speaking as dimension. Okay, so next we have an illustration of an example of the three as to and about dimensions. So this sentence: when I first started dating him, my husband had a man bun just like yours. So it's from the I, it becomes apparent. So in this sentence, the speaker is speaking as a woman, and they are speaking about the husband of the speaker. So that's a man, and so this man bun and yours would suggest that they are speaking to another man, which is not their husband. So speaking as a woman, speaking to a man, speaking about a man. So this is an example of what they mean by the three dimensions. Okay, so the model architecture of the classifiers that they're using is so basically the same architecture and pre-training as BERT-based. And so basically the transformer provides representations for textual input and sets of classes. And classes are scored by taking a dot product between representations of textual input and a given class. So the single task classifier is trained to rank masculine, feminine, or neutral labels for each dimension. So one dimension, as, to, or about. And the multitask classifier will try to rank these three labels for all the possible dimensions given the textual input. So they gathered training data. So there's they use different training data for the different dimensions. So for instance, they have a Wikipedia. So Wikipedia contains quite a number of biographies. So it's a perfect place, of course, to find information about the about dimension, because in a biography, it's obvious that you are talking, that you are writing about someone, and so that is training data for the about dimension. And as for the as in the two dimension, so Yelp is this restaurant review website. So you can review websites. No, you can review restaurants on that website. So when people write reviews on Yelp, it's of course, sometimes you can know, whether they are writing it as a man or whether you're writing it as a woman. So they took this data set from somewhere on the internet, from a previous work, and they use it as training data for the S dimension. So for the rest, Conv AI2 and Lights, I think those are data sets containing conversations between volunteers who, and this is collected. And of course, this is since the data in question are conversations, so you have data as to both S and 2 dimensions, because you'll be speaking to someone who would either be a man or woman or neutral, and you'll be speaking as also someone who is man or woman or neutral. So yeah, so we have also collected an evaluation data set to evaluate the performance of their models, and I'll be talking about it later. So here's the multitask performance of the classifier, of the multitask classifier on the various data sets. So for Wikipedia, you see that it performs rather well on the about dimension. You can tell correctly that something is something is a man 87% of the time. So this is performing quite well, and for the rest, it's if you look at the average, it's performing better than a random performance. So this is okay, I guess. So they have collected a new MDGender evaluation data set, and they want to use it as an evaluation data set to evaluate the performance of their models. So, so what the authors did to collect the data set is that they record down the conversations between people who are given prompts, the form of personas and biographical information. So once these conversations are collected, annotators will rewrite each sentence to make clear that about, to, or as gender information is present in every sentence. So so basically now you have a set of labeled sentences which have ground truth labels, saying whether they are about a man or woman, to a man or woman, or as a man or woman. So that's yeah. So since they have those ground truth labels and the conversations are collected themselves, then they think this would be a good evaluation data set. So this is the performance of the data of the classifiers on the evaluation data set. So for single task, see about single task about forms okay. Single task 2, not so okay. Single task S, okay, above 70%. And the multitask performs best on average, because remember that for the single task classifiers, they're trained on only one dimension, while the multitask is trained on all the dimensions, so performs the best on average. Since their work is based on the premise that models that used gendered words only in classifying not so good, and that other words can have gender meaning that are not explicitly gendered. So they train the classifiers after removing gendered words and removing names. So removing gendered words like mother, father, son, daughter, stuff like that. So these things are obviously male or female. So they remove them so that, yeah, so you're left with the other signals in the in the training data. And they remove names as well, because names can have, can denote gender as well. Say Mary is most likely a woman and Tom more or less a man. So after they remove these gendered words and they train it on, train the the multitask classifier on the Wikipedia test set with those things removed, you can see that they still manage to achieve above random performance, and the performance actually is quite good. So since it still manages to obtain high accuracy, it's kind of suggests that the words in the data set which are not explicitly gendered and are not names still contain sufficient gender information for us to have a relatively high accuracy when predicting the classes. So let's look at some of the applications of that the authors suggest for this for these classifiers. Okay. Okay, so so this is the controlled generation of text. So basically, they take in some input that is neutral or otherwise, and they ask it to generate texts that are to a woman, as a woman, about a woman, to a man, as a man, and about a man. Right. So let's say. So the input, oh, cute. Ours are a handful, but these are my babies, 4-wiener dogs. And so given that input to a man, to a female, it says, I can't wait for your children to get married. I want one so badly. And as a female, oh, that sounds so wonderful. Can't wait to see them in person. So yeah. Yeah, so basically that's one of the applications, and they also look at the genderedness of offensive text, though this is not really that much of application, as it is just a reflection of how offensive text is based on the three dimensions we're talking about. So they're looking at the so they have this data set of text that is either safe or offensive. So yeah, so safe words, safe sentences may be stuff like let's go to the picnic. Let's go for a picnic today. And an offensive sentence might be something like, you are a greedy fat person, something like that. So they see that interestingly in the about dimension, they have relatively more safe male gendered text, and there is offensive male gendered text. But for the 2 and S dimension, relatively we have less safe masculine gendered text as compared to offensive masculine gendered text. So it kind of suggests that men are a bit more offensive when they talk, and that they are offensive when talking about men. Yeah, but so take what you want from it. And so the future. So the authors have this. They feel that okay, so these biases, these gender biases are present in our NLP models because of the biases in the training data, and the training data is biased because society is biased. So so they think that if you have an ideal classifier that 100% hit and miss when you talk about classifying something as a very good classifier that manages to perform very well on their proposed evaluation data set. So if they have an idealized classifier, that it will eventually achieve random performance on a future data set. So basically, it's saying that if you have a future data set that is not gender biased, right? The classifiers, an ideal classifier would achieve only random performance. So the very fact that the data set is not gender biased means that there is no gender information to pick out, and you can achieve therefore only random performance. So I guess this is a direction that the authors might want society to move forward in. And they think that the classifiers they introduce here are the first step towards the goal of creating a idealized classifier. So with that, thank you very much. That's the end of my presentation. Any questions?